Bismillahirrahmanirrahim. We are going to start question number 4 of exercise 2.2, in which we are given this equation of matrices and we are asked to find matrix A. So let's start the solution. First of all, we are going to give names to these matrices. So we are going to call this matrix as matrix B. A will be written as it is, we have to find it, and then this is matrix C is equals to, as this is identity matrix, so we are going to call it I. Now what we are gonna do, basically the roadmap for solving this question is that we are going to multiply BC together, then A equals to identity matrix and A equals to BC. When we find its product over here, then we are going to bring it over here, find its inverse, and then multiply it with identity matrix, and in this way we are going to get the matrix A over here. To solve this question, first of all, we are going to find a product of matrices B and C. B is this matrix and this is matrix C. So first of all, we are going to find their product. So BC equals to, we are just going to write these matrices over here. So B is 2, 3, 1 and 2, and C is 1, 2, 3 and 4. Now let's multiply these two matrices. For the first entry, we are going to multiply the first row with the first column. So we are going to get 2 into 1 is 2 plus 1 into 2 is 2. Then we have, for this entry, it is second row and first column. So second row multiplied with the first column. So 3 ones are 3 plus 2 twos are 4. For this entry, this is first row, second column. So first row multiplied with the second column, we get 2 threes are 6 plus 1 fours are 4. And then we have, for this entry, it is a second row with the second column. So second row with the second column, we get 3 threes are 9 plus 4 twos are 8. Now it equals 2 plus 2 gives us 4, 3 plus 4 gives us 7, 6 plus 4 gives us 10, and 9 plus 8 gives us 17. So this is the product of matrices B and C. Now we have to find its inverse. For inverse, we are first of all going to find their determinant, because when the determinant of a matrix is non-singular, then we can say that its inverse exists. So first of all, finding determinant of BC equals, we are going to write this matrix in these two bars for determinant. So 4, 7, 10, 17. 4, 7, 10, 17. It is equals to, diagonals multiplied together, so 4 into 17 minus non-diagonals multiplied together, we get 10 into 7. So 4 into 17 gives us 68, and minus 10 into 7 gives us 70, and so the answer is minus 2. Therefore, this determinant is non-singular. As it is non-singular, so now we are going to find its adjoint. Adjoint of BC equals to, why are we finding adjoint? Yeah, because we have to find inverse, and to find inverse, we need adjoint of a matrix and determinant of a matrix. We have the determinant, but we have to find the adjoint. So how to find adjoint of a matrix? We are going to interchange the diagonal entries, and we are going to change the sign of the non-diagonal entries. So 17 and 4 will be interchanged, and we are left with the non-diagonal entries, so we are going to write them as minus 7 and minus 10. So this is adjoint of BC, this is determinant of BC. Now we are going to find BC inverse. Why are we finding BC inverse? Because we have to put it over here. So BC inverse equals adjoint of BC divided by determinant of BC. BC whole inverse equals to 1 by determinant of BC is minus 2, so minus 1 by 2. Now we are going to write the adjoint matrix over here. So we have 17, minus 7, minus 10, and 4. So BC whole inverse equals, we are going to divide 2 with all of the entries over here. So 17 divided by minus 2 gives us minus 17 by 2. Minus 7 divided by minus 2 gives us 7 by 2. Minus 10 divided by minus 2 gives us 5, and 4 by minus 2 gives us minus 2. Now we are going to write this equation again over here, equation 1, which is A equals to BC inverse into identity matrix. Now whenever a matrix is multiplied with an identity matrix, it gives the same result. So A equals BC whole inverse, and A equals to, this is the matrix of BC whole inverse, we are going to write it over here. So we have found the matrix A, which when put over here, we get the product as an identity matrix. So this is our answer. Thank you. Now we are going to start the second part of question number 4, which says that we have to find a matrix X, which when multiplied by this matrix gives this matrix as a result. So to find this matrix X, we must know that how many number of rows and columns are there of this matrix. To find the number of rows and columns, we must look deeper into some basic facts. The first one of them is that the number of rows of the resulting matrix is always equal to the number of rows of the first matrix. There are 3 rows in the first matrix and there are 3 rows in the resulting matrix. But the number of columns of the resulting matrix equals the number of columns of the second matrix. So as there are 3 columns in the resulting matrix, so there must be 3 columns in this matrix X. So columns equals to 3. Now we have to also find the value of number of rows so that we can suppose a matrix X. So to finding the number of rows, as we know that the number of columns of the first matrix must be equal to the number of rows of second matrix, so that it becomes eligible for multiplication. And because we are having the result of this multiplication, so it was already eligible. So there are 2 columns in the first matrix, so there must be 2 columns in the 2 number of rows in the second matrix. Now we know that this matrix X is of order 2 by 3. We are going to suppose a matrix of this order, and then by supposing this matrix, we are going to find its entries later on in this question. Let's suppose that its entries are A, B, C, D, E, and F. Now we are going to put this matrix X in its place and find a new step. Now we are going to fill up their entries. The first matrix is 3, 0, 2, 2, 1, 0. Now we know the matrix X, so we are going to put it over here: A, D, B, E, C, and F. And this last matrix is this one. We are going to write it as it is: 7 by 2, 2, 1, then is 11, then 4, then 2, and 2, 1, 0. Now we are going to find the next step over here. Now we are going to multiply these matrices together. So first row with the first column, we get 3A plus 2D. Then second row with the first column, 0, 1 into AD. 0 into A, we get 0, 1D as it is. And then 2, 0 multiplied with AD. So 2A plus 0D gives us 2A. First row and second column, we get 3, 2 multiplied with BE. So 3B plus 2E. Then we have 1B and then 2E. Then we have this first row multiplied with the last column. So 3C plus 2F. Then we have 1C, 0, 1 into CF. Sorry, 1F. And then we have 2, 0 into CF, so we get 2C. I've done some mistakes over here. 0, 1 multiplied with BE, we get 1E. It's not B over here. So now we have to find the values of these A, B, C, D, E, and F variables. To find them, we are going to compare these two matrices, and as these matrices are equal, all of their entries are also equal to one another. So we are easily going to find the values of all these entries. So for the first entry, first entry equals the first one, but first of all we are going to solve all these. This makes the solution more easier because these are simple entries. Now these are entries with double variables, but these all have one variable, so we are going to find the value of these variables first. So 1d equals 2, so we are going to write it over here. 1d equals to 2, so d equals to 2. This is our first value. Now we are going to see over here. The second equation we can get is 2a equals to 1. This first row, first column and last row, first column, last row equals 2a equals to 1. So 2a equals to 1, a equals to 1 by 2. So this is one more result. Now this is the third equation we can get. 1e equals to 4. This is the middle entry equals the middle entry. So 1e equals 4. This means that e equals to 4. Now one more equation we can get is 2b equals to 2. So we are going to write it over here. 2b equals to 2. So b equals to 1. The next equation would be 1f equals to 1. So f equals to 1. Oops. And the next equation would be 2c equals to 0. So c also equals to 0. So these are the 6 results we could get. We know the value of a, b, c, d, e and f, all the variables used in this matrix X. Now we are going to write this final matrix X over here. X equals to a is the first entry, so we are going to write the value of a over here, 1 by 2. Then b is this one, so here it comes 1. C equals 0, so here comes 0. Then D equals 2, E equals 4, and F equals 1. So this is our resulting matrix X, which we were asked to find over here in the. This is question number 4, part 3. We are given with two matrices A and B, and the question is that we have to find another third matrix which when multiplied with A and when multiplied with B both give the same result. So again we have to find the number of rows and columns of this matrix C, which is not known to us, R and C. We have to find the number of rows and columns. For again we have to use the same rules. As there are two columns in the first matrix, for it to be eligible to be multiplied with another matrix C, that another matrix should have the same number of rows as the number of columns of the first matrix. So there are 2 rows in the second matrix. Now we have to find how many number of columns should be here. So the number of columns is similar to the number of columns of the resulting matrix. And as the resulting matrix is of 1 by 1 order, why is it of 1 by 1 order? Because we can see that A has 1 row. So its number of rows is similar to the number of rows of the resulting matrix. So it is the resulting matrix will be of 1 by 1 order. And because that resulting matrix has only one column, so this matrix C can also have only one column. So the order of the matrix C which we have to find is 2 cross 1. So we are going to write a matrix C over here of the same order, 2 cross 1, C equals 2. And now let the elements of this matrix be X and Y. Okay, we have a matrix C which has two elements X and Y, and it has the order of 2 cross 1. Now we are going to multiply this matrix C with A and B as there is given in this question, AC equals to BC. So we are going to write it over here, AC equals to BC. Now we are going to write these matrices A and C, B and C over here. So the matrix A is 3, 7. The matrix C is X, Y equals to the matrix B is 2, 14, and the matrix C is X and Y. Now we are going to multiply these two matrices together, so we get 3, 7 multiplied with XY, first row, first column, and there is only one row and one column, so we are going to multiply them with each other. 3x plus 7y in the form of a matrix is equal to, now this first row, the only row multiplied with the only column, so we get 2x plus 14y in the form of a matrix. Now, as the entries of the matrices are equal, if two matrices are equal, their entries are also equal. So 3x plus 7y equals to 2x plus 14y. Now the next step will be 3x minus 2x equals to 14y minus 7y. We get x equals to 7y. Now we are going to find the values of x and y. There can only be two possible values of x and y. For example, if y is 0, then x would be, we're just supposing that if y is 0, then x will also be 0, and 0 0 will make a 0 matrix, which C is not. It is given that C is a non-zero matrix, so we cannot consider that its values are 0 and 0, so we have to find any other values. For example, if we take y as 1, y equals to 1, then x would be equal to 7. This is possible because if y is 0, then x is also 0, and this is not possible. So we are going to use these values of x and y over here. So x equals to 7 and y equals to 1. This is our solution. And what is the matrix C then? X is 7 and y is 1. So this is your matrix C, which we had to find, and this is the solution of part number 3.